Hi everybody, Mrs. Pesic here. We are looking at the big ideas, and for number one, we are solving by factoring, and this is what you should do to solve by factoring. We want to get everything over on one side, so we'll have 12x squared plus 5x minus 2 equals 0, and then factoring a quadratic trinomial probably means we want to use product sum. So you know that the product sum is going to be the product, I should say, is the A times the C, so that's going to be a negative 24, and the sum is going to be your middle coefficient, the coefficient on the x term, including the sign, so that's positive 5. So the two numbers that are going to work here are going to be 8 and a negative 3. They multiply together to give us negative 24, and they add up to 5. That means I want to take out this middle term, and I want to replace it with an 8x and a minus 3x, because that will add up to 5x. So I'm going to have 12x squared plus 8x minus 3x minus 2. And then I'm going to group these two at a time and factor by grouping. So I can factor out a 4x from the first two and get a 3x plus 2. And I can factor out a negative 1 from the next set and get 3x plus 2. Since I have the same thing in parentheses, I factor that out. And what's going to be left over is the 4x minus 1. Keep in mind that this was all equal to 0. So if I have two things being multiplied together to give me 0, one of them has to be 0. So I set each of these equal to 0. And if I do this, I get 3x equals negative 2. So x equals negative 2/3. That's one of our solutions. And here I would get 4x equals 1. Divide by 4, and I get x equals 1/4. As the other solution. So those are your two solutions for number one. Let's take a look at number two. This time we are solving by taking square roots. Well, at this point I would start to unwrap this so I can solve for x. I would add 12 to both sides as my first step. And then I would divide both sides by 3 as my next step. So I'm going to get x minus 2 quantity squared equals 4. And then my next step is where I'm going to take the square root of both sides so I can undo the squaring. But when I take the square root of both sides, I need to remember that there's positive and a negative answer that are possible. So the square rooting and the squaring are canceling each other out. So I get x minus 2 equaling plus or minus the square root of 4. But square root of 4 is just 2. So I get x minus 2 equaling plus or minus 2. That means I really have two equations to solve. Either x minus 2 is equal to 2, or x minus 2 is equal to negative 2. And so in this case, when I add 2 to both sides here, I get x equals 4. And when I add 2 to both sides here, I get x equals 0. So these are my two solutions for problem number 2. Let's take a look at number 3. This one says solve by completing the square. We cannot make a perfect square trinomial unless our leading coefficient here is a 1. And since it's not, we have to divide everything by 4 in order to get that leading coefficient to be a 1. So now we have a 1x squared minus 2x minus 27 equals 0. Is this a perfect square trinomial? Well, you want to test it. If I take half of negative 2, I get negative 1. And if I square that, do I get a negative 27? No, that does not look so good. So let's get rid of the 27. That's kind of messing things up. So let's bring that over to the other side. And when I rewrite, I'm going to leave a little room to complete the square. So I've got x squared minus 2x equals 27. I take half of this coefficient. Now that I've got a leading coefficient of 1, it's okay to do this, right? I take half of negative 2 is negative 1. I square it, and I get 1. But if I add 1 to the left side to make this beautiful perfect square trinomial here, I'm going to have to add 1 to the right side also to keep the equation in balance. So this perfect square trinomial here can be written as a binomial squared. And it's going to be x minus 1 quantity squared. Remember, this is your clue as to how to write your binomial. So it's going to be x minus 1 quantity squared is equal to 28. And now we're in the same kind of position we were in this previous problem where we had this, binomial squared equaling a number. So in this case, we need to do the same thing. We're going to take the square root of both sides. Don't forget the plus or minus. So I'm going to have x minus 1 equaling plus or minus the square root of 28. Now, square root of 28 can be simplified because there is a perfect square that goes into 28, namely 4. So I can split square root of 28 up into square root of 4 times square root of 7, which is going to be 2 times the square root of 7. So I have x minus 1 equaling plus or minus 2 times the square root of 7. I still need to get x by itself, so I'm going to add 1 to both sides, and I'm just going to put that 1 in front of the 2 rad 7. So my two solutions here are 1 plus 2 rad 7 and 1 minus 2 rad 7, but I can just write the two together like this. Those are my two solutions for number 3. All right, let's take a look at number 4. Here you're solving by a quadratic formula. So in this case, you can't use quadratic formula unless you have everything over on one side. So let's subtract 3 from both sides, and then we get a 3x squared minus 2x minus 3 equals 0. It is now in ax squared plus bx plus c equals 0 form, and the solution to a quadratic equation in this form is given by the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you know the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so when we plug in our values here, we have a equaling 3, b equaling negative 2, c equaling negative 3. And so when I plug this in, I'm going to have x is equal to opposite of a negative 2 plus or minus square root of negative 2 in parentheses squared. Those parentheses are vital, okay? Because if you're going to put this in your calculator, if you don't have the parentheses, you're going to get it wrong. So then minus 4 times 3 times negative 3 all over 2a. So all over 2 times 3. So in this case, I get opposite of negative 2 is a positive 2 plus or minus. And when you work this out in your calculator, you're going to get a 4 plus a 36 over 6. And so that's going to give us 2 plus or minus square root of 40 over 6, but I'm going to split this up at this point and write it as two separate fractions. That's key here because we want to be able to simplify. And if I had left it 2 plus or minus square root of 40 over 6, and I say, oh, I'm going to divide out this 2 with this 6 and write 1 plus or minus square root of 40 over 3, that is wrong. You cannot do that. Do you remember why you can't do that? You can't do that because here we would be dividing out a term. 2 would be a term here. So that's no good. All right, so let's get rid of that. We don't want to do that. Instead, we want to split it up into two separate fractions like we did right here. Now I can divide out and say 2 goes into 2 once and into 6 3 times. And here I can't divide out the 6 and the 40 because one's in a radical and one is not. So I'm going to have to simplify square root of 40. 4 goes in to 40, and that's a perfect square, so I would split it up like this and get 2 square root of 10. So now I'm going to have 1/3 plus or minus 2 square root of 10 over 6. And if I divide the 2 into the 6 now, both of those are outside the radical. They're both factors, not terms. I get my final answer of 1/3 plus or minus square root of 10 over 3. So these are your two solutions for number 4. All right, thanks for watching.